Okay, happy Sunday, everybody. Um, so I got a couple of questions about the architecture, how I'm deploying, what it costs, those sorts of things. So I'm gonna go try to do a pretty big deep dive on this because there was a lot that went into putting this out there. And I did a ton of research before I actually even started building this project to see if I could do it in such a way that would give me, a long runway and would support what I wanted to do. So we'll start with the architecture of the backend. It's uh, not a super interesting or different or wacky or wild system. It's a relatively straightforward kind of 2 or 3 tier architecture. And when I say architecture, I'm talking about the Micronaut app itself, right? The server binary or jar that I deploy. Um, so our very first big box, right? And I'll try and draw this out here in Excalidraw, is Micronaut, right? So we run with inside of Micronaut. We use that for a couple of reasons. One, it is a application framework focused on things like startup time, and when I'm running in a serverless environment or serverless-ish environment like Google Cloud Run, which we'll cover later on, startup time is important. So I went with Micronaut primarily because of kind of this, again, small footprint, low startup time, potentially the ability to compile to Grail VM. I'm not quite there yet. I had a bunch of trouble primarily because of the dependencies and libraries that I'm bringing in, but that may be something that we'll cover in the future. That would give me even faster startup time, lower memory usage, that sort of thing. But for now, I don't really actually need it. So within Micronaut, it's a relatively standard Java app that you'd see. There's kind of this request layer, right? This is primarily I use GraphQL, as many of you who've watched the other streams would know. And so the request layer handles all of the HTTP stuff. It uses JWT, JOT tokens for security, and we primarily use, not primarily, we only use a system called Sign In with Apple right now, and that is JWT based. And I use that primarily because, one, it's free and built in. Currently, the only clients that I have are, well, right now just the phone, but in the future I want iPad, Mac support, and web as well in the future. And Sign In with Apple works across all of those. It's a free and built-in service, and the onboarding and everything's pretty nice. Eventually, I will most certainly need to add just standard email, password, two-factor, but to just get up and going quickly, we went with this. So behind that, and just to kind of call this out, because I have the code up on the left-hand side here, this module is what you'll see over here as the API service, okay? So I'm going to go through a bunch of these modules as well. So actually, I should probably just, so this is module API service, okay? So then after the request layer, we typically have kind of our, what I typically call the service layer, right? This is how we access all of our, primarily our business and domain logic. So this helps us fetch data, manage and authenticate users, that sort of thing. These are just standard Kotlin classes, nothing special, nothing specific. They're wired in via the built-in dependency injection within Micronaut. Below that, we have our primarily Kotlin data classes. And these data classes, couple interesting things about them. One, I treat them primarily as immutable. So if I need, if you look at any of my data classes, these are all actually val. There's almost no usage of var within any of the data classes, primarily just because that, for the most part, seems to work for me. There's not a ton of mutating on the fly data. And so if I can keep things immutable end to end, whether it be a request coming in or data going out, that seems to work pretty well for me and not get too hairy. This does have some issues with when I have to transfer data between modules, but I'll get to that a little bit. So the API service, there's really not much in it. There's, again, a request layer, a service layer, or a business and domain logic layer. And to be honest with you, the business and domain logic in here is really only for the API service. It does not include a lot around fetching data and that sort of thing. I've got more about that, and we'll talk a little bit about that more. Okay, so the next big one is what you will see here. I'll zoom up, is the data module. This is just a standard Kotlin library that I made myself, and it has lots of services in them, and the services map to things like auth. It maps to things like quotes, and then it maps to things like, watch list, other things like that, right? Things that you see in the app. And this is where a lot of the actual business kind of domain logic lives. Admittedly, there's not a ton of it, but most of the data processing and services for accessing data or updating data live in the data module, okay? Next, I have what I consider to be kind of my database layer, and that is the Firestore module. So we use Google Cloud Firestore for our primary data. It acts very much like MongoDB if you've ever used Mongo, although it has, a whole host of other things there. We'll talk about why I picked Mongo and why I actually pivoted away from Postgres very early on in the project a little later on. But Firestore is my data source of choice right now. It stores all of the both user data as well as acts as kind of a persistent cache for the market data and quote information. So in here, you'll see things for, quotes, watch list, on and on and on. The other thing that's in here is that this layer has a built-in in-memory cache. And so some of the previous streams, we took a look at how I do caching. Most of the caching is done at this layer. So anything that pulls in this Firestore will kind of get the caching logic and caching behavior for free, right? So, and I'll zoom out here, because if you look at like a typical request, right, it's gonna look like something like this. A request is gonna come in. It's then going to, go from here to here, right? And then also probably from here to here. And so this way, all of the caching logic is housed, in this layer. And so that way, nothing else has to worry about where it's getting its data from. And the caching is super important because the major reasons why I chose many of these products is primarily because they are usage-based. And so I have to be a little careful as usage goes up on the app that I'm caching data appropriately, because I get charged for every read or every write to Firestore. So this way I can keep all of the logic around accessing Firestore and if data can be cached or not in this in-memory cache. And the nice thing is that this in-memory cache is just Micronaut's implementation, which has a number of different supported backends. So right now, I actually can get away with only running one instance of this server. And so I'm just running it in memory. I don't need to pay for or utilize or spin up a Redis or something like that. But in the future, I can. And it's very easy to swap that out. So as I scale, I have the ability to swap out this in-memory cache for something else. Okay. I then have a couple other modules. I have the IEX client. This is a API client for IEX Cloud, which is one of my, or kind of the primary data provider for much of the data that I'm getting. It also has domain objects for IEX Cloud specifically. Again, like I said, most of my objects are immutable. And so I will have objects that just manage this, and then I will create extension functions for converting, say, a quote from IEX Cloud to a quote in Firestore, or a quote in my kind of my domain or my data module, right? So this is, again, just an HTTP REST client. It's using HTTP and retrofit. So there's very little code in here. It's essentially just an interface and some data classes, which is great, right? What else? The next thing that I have is something that I made recently that was a bit of an experiment, but it worked out super, super well. And that is using, well, actually, let me back up. One of the needs that I have within the app is for you to be able to type in a company name or a symbol, like a ticker symbol, and get like type ahead for a stock. And there's a API call that I can do with with actually many of my data providers to do that. But again, almost all of my cost is usage based. So it made a lot more sense for me to try and come up with ways to get as many of the stock symbols or company names in some sort of a database, and then run like a full text search on that. And what many people don't know is that SQL Lite has a full text search, and a pretty good full text search system built in. So rather than have a huge index and run a query across Firestore, or use this IEX client and rack up charges, well, I would rack up charges on both of these. I decided to create a job that would pull down as many symbols and company names as I could from my data providers, and then I store them in a SQLite database. And this has a ton of interesting benefits. So I put basically, I have a job that, like I said, grabs all of this data and puts it into a small SQLite database that lives on disk. And so this SQLite database, right, this search database, is only a couple megabytes. I ship it in the app or within the jar, and then I actually open it up as essentially an in-memory database. And again, it's only a couple of megabytes, but I have, thousands, hundreds of thousands of symbols in it and company names in it. And then I use this for full text search, right? I use it for type ahead, autocomplete. And I have some other data in it, I've actually, because this has worked out so well, I'm planning on putting more data into it because it works super well. And so again, I'm using this as an in-memory database right now. And so this is just what I use for SQL Lite. And what I use for access is a library called JDBI. JDBI is a really wonderful kind of data access library in Java that works very similar to how OK, HTTP, and Retrofit work. And that is, you just write an interface and then you write some SQL queries with annotations on it, and you have a SQL client. And this works with, more than just SQL Lite. You typically use it with Postgres, MySQL, whatever. But because it's Java and the wonderful ecosystem that is JDBC, you get all of this for free. So I am able to ship a super fast, highly functional, full text search system in my app, all with an embedded couple megabyte database. And I update that database not super often, but every once in a while. And it provides super fast search across hundreds of thousands of rows in my app, which is awesome. So what else do we have? That's SQL Lite. Scraper is an experiment. That's not super exciting right now. NASDAQ worker. There's not much there. The NASDAQ worker just pulls information from NASDAQ has a FTP site that they provide public data for. It's, again, another one of my data sources that I use. I don't run it very often. Last but not least is the notification service. And so if we go back down here, and I'll draw, this thing here, right? This is essentially the app or client. The last thing is another Micronaut service. And this is the notification service. One of the big features of this app and system are push notifications to tell you when your stocks go ex-dividend, when you're going to get paid, paid dividends, and amongst other things I'm starting to add and think about, what other notifications would be useful. And so this service lives internally within Google Cloud, and we'll talk a little bit about that and why I did that. But this basically sends push notifications on a schedule. And in order to do this, I actually use a feature or a tool within Google Cloud, which we'll get to in a little bit as we talk more about the deployments. And within Google Cloud, there is a great scheduler service that can schedule, you can schedule jobs. And so basically there is a timer here with that scheduler. It hits the very basic request layer, and then basically that will then send notifications to it, right? So we'll just put this here for now. This is the GCP scheduler. And we'll go into more of this in a bit. But those are the major items, right? So I'm running I have deployed 2 of these Micronaut apps. And then from there, these apps rely on some of these modules, right? So that's the rough overall architecture. Again, it's nothing too interesting, nothing too different or out of the ordinary. A request layer, a service layer, and kind of a data layer, right? Not much to it there. some of the choices I made are maybe a little interesting, a little unique. This SQLite thing was an idea that I got from Peter Levels, who runs Nomad List, and he actually runs his entire site on SQLite. And one of the major, well, we'll get to that in a little bit. I won't go into that. So again, this is the architecture, nothing too exciting. If you have any more questions, just let me know. But I'm going to leave this up because we're going to come back to this and kind of annotate more when I talk about the deployment. So let's talk a little bit about infrastructure. I want this to run. Let me turn this off. Let's talk about kind of some of the the driving factors behind what infrastructure I'm using and why. The very first one, and this is a big one, is needs to run for free or basically free. And really what that really means is that this needs to scale with my users' usage over time. So this is going to be an app or a set of apps, right? Paid subscription app that's going to have a free tier of some sort. And I don't want to be overwhelmed with infrastructure cost. It's going to, this is something that I want to build and maintain for many years to come. And, I don't want to make the mistake of, getting overwhelmed or overburdened or having to pay a ton of money as I continue to build things. I'm not expecting this to be an overnight success or a home run. So I want to be able to build and maintain this for quite a bit of time. And so in order to do that, right, it needs to be something that's relatively cheap to run. Second thing, it needs to be backed by a major cloud vendor with a strong set of automation tooling. And what do I mean by that? There's a bunch of different moving parts to this, and I want to be able to automate this as much as possible. When things go down, I want things to spin back up. When I want to add a new thing, I want to be able to do that declaratively in code. And so I don't want to be hunting and pecking around and tapping buttons in a cloud console, right, to get what I need. So that's really the second thing. And finally, I need it to be, I need to be relatively agnostic to a point. Now, this one, I think people spend too much time on making their stuff agnostic. One of the reasons, or one of the things that I do, right, is use a framework like Micronaut or Spring Boot or something like that, right? This will give you a ton of, or a nice facade or layer between you and the various, your cloud provider of choice or whatever. So if you're doing a queue, say you need a queue service, right, or a queuing mechanism, and if you're using Micronaut or Spring Boot, those have, just as for example, the cache service that I'm using in Micronaut, are a great abstraction. So if you need to move from Google Cloud Pub Sub to AWS SNS, right, you really shouldn't have to change almost any of your code, right? This does not mean for me, like it does for many companies, maybe running RabbitMQ. That's not what I want to do. Again, I want to run as few servers as possible. And I want this to run for free and scale with my users' usage. I really don't want to have to run and manage and patch servers and all that kind of stuff, right? So I want to try and be relatively agnostic. Again, I'm using Micronaut for that. At the same time, I want to utilize built-in primitives where they're available. So one of the things that I talked about is I use the GCP scheduler. I use a built-in database that Google has called Firestore. it's effectively a document / NoSQL database. Every cloud provider has one. So if I need to switch or I need to change, I would likely only have to switch out this Firestore module, right? The data classes shouldn't change. The interface shouldn't change that's in here. And I would be able to do that, right? Again, it could be any other thing, but for now, that's just what I'm using. So those are kind of, at least that's my thinking behind why I chose what I did, and what's what kind of drove a lot of my decisions. So let's go a little further into the details of this. Okay, as I mentioned, part of this is that it's backed by a major cloud vendor with automation tooling. The automation tooling doesn't actually, in this case, come from the vendor itself, doesn't come from Google Cloud. It actually comes from a company called HashiCorp. And I am using Terraform to allow me to declaratively say, this is the infrastructure that I want, this is the infrastructure that I need, no more, no less, connect them together, secure them, and then, if something goes wrong, if I need to spin up more infrastructure, if I need a test environment that looks identical to my production environment, I can very, very, very easily spin that up. So it's well worth the time and effort to learn one of these tools. There's a bunch of them out there. Terraform is just my my weapon of choice in this case. And I did not use Terraform before this. It took me maybe 2-3 days to kind of get up to speed and get comfortable with it. And then from there, I was able to build out my entire infrastructure in a day. So pretty cool. So let's take a look at Terraform, because that will kind of yield us some more interesting information about what all I'm using, because we haven't quite talked about everything yet. So one of the first things you do with Terraform and with Google Cloud is you have to enable the APIs or the services that are available in your Google Cloud account or your project. And so in my project, I am using Google Cloud Container Registry. So I am taking my jar files for my notification service and for my API service, packaging them as a container with a Java library called Google Gib, which is built into the Gradle process, and it packages those classes into a highly optimized Docker container and then pushes that to Google Container Registry. Okay, so I've enabled that API. Second API or service that I have turned on is Google Cloud Run, and Google Cloud Run is what is actually running and managing both my API service and my notification service. This right here is really what enables me to do what I'm doing with extremely low cost and very little management from my perspective. If you've ever used Heroku, which many devs have, to me, Cloud Run is like the next generation of what Heroku kind of should have. I wouldn't say should have been, but what it's more like Google's take on Heroku. And so I've been super happy with it. It gives me a very similar Heroku-like kind of build, run, deploy cycle. And if you're familiar with Heroku, you will be pretty at home with Cloud Run. And all Cloud Run is just takes a container that I've pushed into Container Registry and then runs it kind of like a serverless function. And so again, one of the reasons why I chose Micronaut, fast startup time, low memory footprint, is because Cloud Run will automatically scale up and down based on parameters that I set or based on usage. And its cost is extremely low because you're only paying for when your service is both running and actually serving a request. So again, this goes back to speed and caching and being performant, right? The faster my system performs, the more requests it can serve, but also the cheaper it is, because if it serves those requests faster, I'm only getting charged for that, right? So that's Cloud Run. There is an awesome book about Cloud Run and about all of the details. Yep, right here. Building serverless applications to Google Cloud Run. I have a copy of this. I've read it and I refer back to it all the time. It's a super great book. There's a lot of nuance and intricacies about how Cloud Run works that if you're not kind of aware of, you may get yourself into trouble or may try to use it in such a way that doesn't necessarily work. But if you know those things, some of which are limitations and some of which are changing and being patched. But at the same time, some of them actually have a ton of things where you can take advantage of them. So highly recommend this. It's a great read. And again, I refer back to it all the time. So next API, Google Cloud Firestore. So Firestore is a document kind of NoSQL database. It is something that is a part of the Firebase ecosystem. Although I actually don't use Firebase really for anything. I just have Firestore, the database, enabled in Google Cloud. So I use Firestore as my primary data store for both user data and for kind of market data and caching of that data. Secret Manager. Secret Manager is how you store your secrets for really anything within Google Cloud, but I am storing sensitive API keys or certificates and things like that in Secret Manager. And then basically my API service and my notification service call out to Secret Manager when it needs something like a certificate or an API key or something like that. And Google kind of manages keeping those secrets safe for me. Finally, the scheduler. So this is how I schedule notifications to be sent at a certain time. So right now, for example, every weekday morning, I send a notification to everyone that says, hey, you have companies in your watch list or in your portfolio that are potentially paying a dividend, or they're going ex-dividend today, meaning they're announcing a dividend, right? Or ex-dividend means like if you own the stock on or before this day, you're going to get paid the dividend, or if a dividend's been declared. So I use the scheduler. I'm going to start using the scheduler a lot more because I have a bunch more ideas on notifications to be sent. And so Google Cloud Scheduler is like your watchdog or your timer, right? Your cron for all of your Google Cloud stuff. And so one of the things to know here is that Google Cloud Scheduler doesn't actually do the work. It's just kind of like a tick or a nod to be able to do something. So this just sends a request to my notification service, and it's an internal only service, so I get all of the benefits of Google Cloud's actual authentication, and we'll talk a little bit about that. But this is just a way for like a tick or an event to happen so that you can actually trigger some work, right? So those are the main Google APIs that I use. So how do those kind of fit in here? So what I'm going to do is draw some more of these boxes, and let's change the stroke to blue so that it looks different. So this is Firestore, right? So this is the database of choice. And again, this module deals with access to Firestore. I already kind of put this scheduler up here, but what I'm going to do is I'm actually going to delete this and move this over because I want to try and make it more logically correct. If we draw, so then we're going to draw a big box. Effectively, we are deploying everything. These two services, this is kind of within Google Cloud. And within Google Cloud, the app and the client live out here, right? So everything was in Google Cloud. And then I'm also utilizing, like I said before, the scheduler doesn't actually do any work. It simply triggers a notification right? Tells this thing to run, right? And then this thing sends out the notifications to the phones, right? So this is all internal. This is not exposed to the public internet in any way, right? But this can kind of come through here. Okay, so these things, as I mentioned, both of these are using Google Cloud Run. They can auto scale if needed, or this is set to auto scale if needed. I am nowhere near needing to scale right now, which is great. And again, as long as I continue to kind of optimize and keep an eye towards performance, this should get me really, really, really far, which is great. And so the other thing that we have in here that we talked about, right, is Secrets Manager. So this just sits in here. There's a API for it, and I call that from both of my services for sensitive things, API keys, certificates, things like that, right? And then Container Registry is the final one, right? Container Registry. This is just storage for Docker containers, right? It's worth noting too, wondering how do I get this into Container Registry, right? So this code lives in GitHub, and I set up GitHub Actions, which is a free CI/CD system, and GitHub Actions, and we'll draw this maybe over here, right? This is GitHub and GitHub Actions, right? This pushes the stuff into Container Registry. So whenever I commit on master, or whenever I create a tag, it automatically builds the code, connects to Container Registry, and pushes that container in there, right? And so I typically run in a trunk-based fashion. So on every push to trunk, build and deploy code to dev, on every tag, and basically I have a tag filter that looks something like production v whatever, like my version, deployed to production, right? So I have this set up. It's really straightforward. There's nothing super exciting about it. It uses the built-in actions tools for doing this, and so it's pretty straightforward. There's nothing too exciting there. So that's how we get our code into Container Registry. So let's take a look at some of what else we have in Terraform and what else is interesting, right? So the first thing I do in Terraform, as I mentioned, is we enable these services. So if I wanted to create a new environment or a new project, right, I could just, type in a few commands and this would go off and do its thing. So we have things for our API service, okay? So our API service has a couple definitions. I tell it, hey, I have a Google Cloud Run service, right? Currently, my max scale is 1. You can tell it the concurrency, meaning how many requests do I expect this container to be able to handle before you need to auto scale. Point it to the image. You can tell it how much CPU and RAM you need. So, I'm running under a gigabyte, 1 CPU core. Traffic. So whenever I push up a new container, GitHub Actions pushes this in here. This will get triggered, and it will push that new container into Cloud Run and start serving the traffic to be 100% if it succeeds and runs successfully. I have domain mapping, right? So I have my custom domain set up, so I can do API.whatever as my domain. And then finally, you have to give it like some access role, right? And so in this case, I'm telling it this can allow outside access, right? Meaning I can accept traffic through my public API URL. And this has, Google Cloud Load Balancer in front of it with all of their goodness, right? So this is really what a a Cloud Run service looks like. You'll notice I have the exact same thing for the notification service. It's another, Cloud Run service that lives, spins down when it's not in use. I only pay for the notification scheduler when it calls and tells it to do its work. In this case, this has a specific service account name, and that is tied to this service alone. And so you'll see in the scheduler, this is how I do not expose this to the internet. It's running only internally within Google Cloud. And I've specified that only the scheduler can actually call this service to trigger it. Okay. But, again, nothing too exciting. 1 CPU, less RAM. This doesn't take a whole lot of work. So not that big a deal. If we look at the scheduler, you'll see it's really just the definition of cron, as well as saying, hey, do a GET request against this Google Cloud Run service and use this token, right? So I send, this is the weekday morning notification. It's on a schedule, Monday through Friday at 6 a.m. New York time. In this region. And so as I add more jobs at different times, I just come in here, duplicate this, add another, set a new time or schedule, and we're good to go. So last major thing is Firestore indexes. So Firestore does have indexes if you want your data lookup to be fast. So I can set my actual indexes for my data to keep my data access nice and quick. And you can set that in here. So it both creates the database and then also sets the indexes automatically, so I don't have to manage those. So that's really Terraform in a nutshell, right? It manages and sets up all of this stuff. The last one's probably this thing called secrets, which isn't super exciting, but this is just how I push tokens or certificates into the secret manager. So you give it a file, nothing too crazy there. So this is how all of this gets deployed and run. If I wanted to spin up a new infrastructure or new environment, I could do that in about 10 minutes. I would run Terraform apply, give it a new project name, and it would go out and spin those up. One interesting thing about this is that I have multiple environments set up, right? So I have a staging and production environment. I do not keep the Terraform state in the repository. There's a bunch of sensitive stuff that is in your Terraform state. So I do not keep that in there. But you can specify your Terraform state to be held outside of your repo. And so I have this actually set up to live in a folder in my Dropbox so that when I am going between, sometimes my multiple computers, it knows exactly what state is where in my different environments. And so I can, safely plan and apply from different computers without having to manage that. There is a free tier for HashiCorp. I don't know if it's cloud or whatever it is. They have a HashiCorp as a cloud service that does this. But I just haven't set it up yet. The Dropbox thing seems to work pretty well for me. So for now, we'd kind of just go with that. So those are really the big pieces. Again, I spent a lot of time thinking about this and researching this early on. Everything that I do or everything that is deployed is pay per use. So like I said, Cloud Run, you only get paid for when your server is actually actively serving a request. Container registry, the free tier is great. You're only paying for the storage of your containers. Scheduler, you get, I think, 3 free jobs per project before you get paid. And then it's like, I don't know, $1 or something like that per thing. It's super cheap. And then Firestore is super cheap as well for the most part. It has a very generous free tier, and then reads and writes, are pretty cheap as well, and they come in buckets of 50,000 or whatever. And again, this is why I have spent so much time on caching and take care of that, because a lot of the data that I have in Firestore can be served from the cache in a lot of cases. And so the in-memory cache greatly reduces my writes and reads to the database. So for now, I've got somewhere in the neighborhood of a few hundred people using exdividend in the public beta, and so far my cloud spend is absolutely zero. Which again, this is exactly what I want. I want it to be very cheap for me to run and manage. I don't want to have to worry about it. I want to push all of this complexity off to Google Cloud to let them handle. And so far they're handling it quite well, as I would expect them to. And I have incurred a very, very little / no cost until now. I do expect to, end up having to pay and incurring costs later. But my hope is that only that only starts to occur when I get more users and when people are actually paying for the app or for the site, or whatever I do in the future. So if you have any questions, let me know. There's tons of stuff in here that I've had to both learn and research and think about. The Micronaut documentation is fantastic. The Google Cloud documentation is actually really good as well. I know I mentioned the Google Cloud Run book. I'll put that in the comments or in the description, so you can take a look at that. And I'll list out these services as well that I use in the description of the video, so you can check all those out. So I don't think we'll do any coding today. We might do some later tonight, or maybe earlier this week. We got some the final major features and finishing touches to put on the app before it's launched publicly. And we're getting close. I actually have been testing the final feature myself for about a week or two now, and I think it's about ready, which is portfolio kind of tracking and management. So right now you only have the ability to check out a watch list in the app, but we want to be able to add our portfolio, all of our holdings, and to kind of see and calculate your return based on dividends and such. So that's coming very shortly. So again, if you have any questions, any thoughts, please let me know. I will put links to everything that I use in the description. And I would also to keep in mind, there are ways with both Amazon and Google Cloud and others to get free credits if you're a startup or things like that. So keep an eye out on that, right? If you're starting a new project, try to keep your costs low. I would say I'm really getting a ton of value out of this. I'm deploying and building things really in a fully automated fashion, like I would at work or in a corporate environment, right? Full testing, CI/CD, things like that. And we typically pay a lot of money for that in the corporate world, right? For good reason, for support and other things like that. But there's no reason you can't get the same benefits for your personal projects. Which for me, with this automation, right? I spent maybe a day, 2-3 days setting all this up. This has really allowed me to focus really, really, really heavily on the actual product, the service, the performance, things like that. So don't overlook some of this. A little bit of time and effort into being able to connect these pieces in an automated way goes a long way. And it's been a lot of fun, learning about it, setting it up, and actually being able to see it in action, work the way that I expect it to, and be able to try and build a great product for people. So that's it for today. We will catch you in the next stream.